بسم Bismillah, alhamdulillah, salatu wassalam ala Rasulullah sallam. So last time we compare between solid, liquid, gas, and we say all of these are physical state of matter, right? It doesn't have relation with chemical structure. And we compare between the size in case of solid and liquid and gas. We talk about the mass, we talk about particles arrangement. Let's talk about arrangement, movement. Can particles move around each other here? Can particles move in case of solid? Of course not. It is in fixed position. Why it will be in fixed position? It only doesn't. Does this mean that they don't have any type of movement? No, they have type of movement. We call it vibration. So every particle vibration. Sorry. They have type of movement. We call it vibration. They vibrate in their position. Imagine them in a string and they are moving up and down, slowly movement. So every particle of them can move a slight up or down, but they don't have enough space between the particles to move around each other, right? Because they are fixed in their position and they have strong bond and long and no space to move at. If we talk about liquid, they have a little spaces between them, so they can move a little bit more than solid and less than gas, right? So we can say that particles can move around each other. What about gas? Gas is freely movable. So it can move in any place and any location because it have a lot of spaces between them, right? And this can explain why the solid have the same shape and size. It can change their size. Why they can't change their size? Because the particles here will be fixed in their position. While if we are talking to water or a liquid, we can see that they can change the shape of them according to the shape of the container they have, because they can move around each other a little bit. And if we move here, this can explain why the gas will occupy any space it will be, because the particles can diffuse and move easily from a place to another, right? So if we talk about movement, because this is very important, we can say that movement depends on two things. Number one, energy, amount of energy the particles has, and number two is intermolecular force or intermolecular bonds. So give example in case of solid, the solid has lower energy, so particle doesn't have a lot of energy, and in the same thing, the bonds between them is so strong. So this is why they can't break easily and they can't move. So this is why it is solid. If we move to liquid, it can be in between energy and intermolecular bond between both the solid and between the gas. If we are going to the gas, we can say that the particles has a higher energy than solid, and it has lower intermolecular bonds. So there is no strong bonds, so they can move easily. And this can explain the movement of everything. And they can explain another thing, we will talk about it right now. We will talk about how the matter change on a state of matter. I think we all know this, and even without chemistry, we can understand it. Change of state of matter, before we explain it, we have to differentiate between two things. You have to differentiate between what we mean by physical change and between chemical change. Okay, I don't want to connect it here because it's not, we are talking about types of change, chemical and physical and the chemical change. So what is the difference between them? In case of physical change, if the matter go through physical change, no change in structure of matter, no change, not structure, we can say no change on type of matter. while here a new substance will be formed with a new characters. Let's give example. So for example, if we have here, if we have water in the form of ice, and then it go through melting. Right now it is water, right? After converting into water, does any characteristic of the water change? Did it convert, for example, did it convert to another material? No, it is still water, but you just melt it down. This is a physical change. And from here, you heat it more till boiling, and it converts into gas. Okay, so melting or boiling, all of them, we will consider it what? We will consider it a physical change. Even dissolving substance to make a solution, we can consider it a physical change. We just change the shape of the matter from solid to liquid to gas, but does this mean that the characteristic of the matter will change? Of course not, it will be the same. But the opposite will be here in case of chemical change. Give an example if you wanted to make a cake. So we put some egg over some, let's say, wet, and we put both of them in oven, and we have a delicious cake. Right now, does the characteristic of cake has the same characteristic of egg? Is the same like egg? No. Is the wheat like egg? No. We make a new thing. The same here. Let's say if we have carbon, like the coal, we make it for heating and boiling and making. If we making barbecue or something outside, so we have coal here, right? And you burn it down with fire. So you react it with oxygen. So C plus oxygen, and you form a carbon dioxide, CO2. Right now, does carbon has the same characteristic like also CO2? Of course not. I have made a new characteristic. I have made a new compound with a new characteristic. So this is the main difference you have to understand between physical and the chemical change. In physical change, the matter will have the same characteristic, while in chemical change, it will have different characteristic. Okay? Jump to the topic. So if you have a matter like this, we talk about solid, liquid, and gas. And we always judge the matter in room temperature. So in room temperature, one matter will be liquid, water will be liquid. In room temperature, the oxygen will be gas. Of course, if we change the temperature, if it's too high or too low, it will change the state of matter. Let's say you are traveling to Mars. Of course, the water might be ice on Mars, right? Because it is too cold. But back to our topic, we are judging the state of matter using the room temperature. Usually it's the 37 to 38 or 38 and something, depending on your country. So this is the room temperature. If we are talking about what is happening, how a matter will change from a state to another. So the matter can change from solid to liquid and from liquid to gas. And this might have an inverse change. There might be an inverse change, like changing from gas to liquid and from liquid to solid. Okay? And the most famous example we might explain with is water. So water, in case of solid, it is ice, right? Then it will convert into what? It can convert into water. And then it will convert into steam or vapor. You have to know the different name of the gas of oxygen, because he asked you in exams, what is the other names of water after in gas state? You can say water in gas state, or steam, or vapor. Okay. Back to our topic. So from solid to liquid, what will happen in this direction and what will happen in the different direction? So let's draw an arrow here, and let's draw an arrow here to explain. Okay. So in this arrow, we are giving energy. So we are giving an energy. Okay. So you give the matter energy. While here, you take energy. If you are converting solid to liquid, we call this what? We call this melting. Let's make it in another color. We have a lot of colors. What other color? Okay. We can say it is melting, right? If we are converting liquid to gas, we call this what? We call this boiling. If we are converting gas to liquid, we call this what? We call this condensation. If we are converting liquid to solid, we call this freezing or solidation. So this is how we can understand the change in matter. Solid to liquid, melting, liquid to gas, boiling, gas to liquid, condensation, liquid to solid is freezing. Here you are giving energy, and here you take energy. So if you put something in a hot place, or you put some, let's say we put some ice over a burner, right now I am giving him energy, right? I give it energy. So it will start to convert it to water, and after a while it can start to evaporate and form the steam, right? So in here we give energy, right? The opposite, for example, if you put it in a refrigerator, right? What will happen if you put it in a refrigerator or inside fridge? What will happen to the water? So I don't have a cup of ice. Let's say I have water. If you put it in freezing, what will happen? It will start, right now the energy is not taken. The energy, guys, energy always moves. Energy moves always from the higher to lower temperature. So right now, which one has higher temperature? The matter, the water. Which one has lower temperature? The fridge. So what will happen? The energy started to move back from the water back to the surrounding. So I am taking energy. I'm not giving energy. I am taking energy from the matter. So the opposite will happen when you take energy. So why energy matter? Actually, when you give energy, so why energy will matter? Okay. If we have energy, let's talk about giving energy. If we are giving energy, what will happen? When you give energy, it will go to the particles, and it increase the kinetic energy. Increase the kinetic energy inside the particle. So right now you give it what? Thermal energy, heat. You give it thermal energy, you give it heat. It started to increase the kinetic energy. When you increase the kinetic kinetic energy between the particles, what will happen to the bond between them? If this started to move up and down quickly, and this started to move up and down quickly, the bond will break. So the bond will break, so it will convert into another state, right? So energy increase the kinetic energy, so it will break bonds, right? Break intermolecular bonds. So it started to release, right? It started to convert it from one state to another. And the opposite also will happen in case of if you take energy. In case if you take energy, the opposite will happen. So you are taking thermal energy. So what will happen to the bonds? The particles started to slowly moving, and what happened to the bonds? The bonds intermolecular bonds will become stronger. So it will be the opposite, right? It will go from steam into liquid, and from liquid to gas, right? So it will be formed. We can say it will be formed. So the opposite will happen. So this when you give energy, and here when you take energy. And let's continue inshallah in next lesson. See you inshallah. Assalamu alaikum.